All right, today we are talking about more refraction and something called the critical angle. So you might see here a ray of light coming in, and you can see it bending and refracting. As I adjust this, you're going to see that I'm going to reach something called the critical angle. And I'm going to slowly approach and twist and twist and twist. So you should see a little bit of a rainbow. Welcome to Pink Floyd. And as I go a little bit further, there is no more refracting. As a matter of fact, there's only reflecting. You can see on the inside. So let me go back. When I reach critical angle, I reach what's called total internal reflection. So let me go back. So here is some refraction. This only works when you go from a high to a low index. I'm going to just keep going and going and going, and then I reach critical, and all I can see is internal reflection. Here is a different shape. I'm just going to rotate it. Again, you can see some internal reflection already. It's got a little magnification thing going on here. You see reaching a rainbow. I have internal reflection, but I haven't quite reached critical angle just yet. I'm almost there. As I turn it just a little bit more, now I reach internal reflection. So I reach critical angle. So I'm going to tap this. So it's refraction that happens when you go from a high to a low. It's not going to happen over here. And there's so much bending as it goes that you reach a point where it no longer refracts at all. Let's see, I have one more little piece here that we can do. And again, you can see a lot of bending. You can see the reflection already because there's some. And as I bend it and bend it and bend it, it's right along the surface. If I were to draw a normal, this would be 90 degrees. And then you get your little Pink Floyd rainbow effect, and boom, total internal reflection. So critical angle, we're going to define that. Let's get some notes going here. I know you have your papers. Hopefully you have your papers. All right, so let's talk about what this means. So we're also going to talk about speed. We've sort of mentioned that already. So first part is, what happens to the speed of light? Well, the speed of light is 3 times 10 to the 8th in a vacuum. Of course, when it hits air, it's a little bit less, but we basically treat it the same. The index of refraction divided into the speed of light will simply give us the velocity. So for example, if I would like to find the speed of light in carbon tetrachloride, I'm going to say V of S equals 3 times 10 to the 8th over 1.46. So I have to look it up, and that's why you have that on your notes. So, clear. 3 second EE8 divided by 1.46. It's going to be 2.05. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th meters per second. Most of these velocities you're going to see are pretty fast. They're still going to be times 10 to the 8th. They just will be numbers less than 3. So let's talk about what happens to speed in multi-layer. So without even using a protractor, without doing the math, let's just look at the indices, okay? When I go from 1 to 3, we're going to slow. When I go from 1.33 to 1.61, it's going to go slower because I'm taking 3 times 10 to the 8th, and then again, we're going to go fast, fast. Okay, so let's just say that I have a normal, and I'm coming in. Doesn't matter what angle. All I know is this is going to slow down and cause it to bend toward the normal. Draw in a normal. Now it's going to bend even more, so I'm going to make it super tight. So it should look bent. Do your best to make it bend. And then as you go back into the air, it bends away. So we put these on here. So for each layer, the velocity is going to be 3 times 10 to the 8th meters per second. Air will be 3 times 10 to the 8th meters per second. All right, so what about water? Well, we gotta do the same thing. 3 second EE, 8 divided by 1.33, you're gonna get 2.26 times 10 to the 8th meters per second. 3 second EE, 8 divided by 1.61, you're gonna get 1.86 times 10 to the 8th meters per second. You literally have to just take the speed of light in air and divide it by the index. And so, same picture as before, I'm not getting all the angles in here, but I'm showing how it bends towards and away. So slower is always gonna be bending towards the normal, faster is gonna move away. All right, so let's talk about critical angle. Critical angle is the angle reached when light travels from a high density to low. It's the angle that causes the refracted to be 90. So let's call this is substance 1, substance 2. This has to be a high index, and this has to be a low index. That's all I know is it has to be high to low. And it means that whatever the ray is coming in, call it theta critical, causes this to be 90. So your refracted ray, make it kind of fat, is that. So 90 degrees only happens when you go from high to low, from substance 1 to 2. The critical angle causes it. And then if you exceed that, then you get that internal reflection, excuse me. So the sine of theta that we want to get this is the low over the high. It will always be the low over the high. So let's do this one. So critical angle, so I'm always going to draw a picture. There's my substances, okay? Theta C. It says calculate the critical angle. Well, there's no other substance. If there's no other substance, then you have to just determine, they mean air. So 1.46 and 1. That means the sine of theta critical is 1 over 1.46. So how do we find that angle? Let's do it. Okay, so we're going to take second sine of 1 divided by 1.46. Oops. There we go. So it's going to be 43.23 degrees. That's the angle that causes that kind of refraction. Notice if you did that with, if you get the numbers upside down, if I take second sine, I do 1.46, oops, divided by 1, you're just going to get error. So that's how you know that it's upside down. All right, let's do one more. Let's do the critical angle. So sine theta C, diamond, 2.42, 1.33. Okay, so it's always going to be the lower number over the higher. All right, so you're going to do second sine 1.33 divided by 2.42. Boom, 33.34 degrees for those substances. Many times they're going to assume it's air and you won't have a second substance, but it always has to be going from high to low. All right, you have some practice.